All right, so our lesson today is on using that skill that we've seen before, completing the square, to now rewrite our quadratic functions into vertex form. So a reminder of what it looks like when you're identifying a perfect square trinomial. So the first term is a perfect square, last term is a perfect square also. And when we multiply the x times the y and double it, it gets us what's in the middle. It's just a matter of, do we have a plus here or a minus here? So if it's a plus, it makes x plus y times itself. We say x plus y as a quantity squared. And if it's a minus, right, then it's x minus y times itself, or x minus y as a quantity squared. Let me give you one example before we work through our problem set. So let's say that I give you x squared minus 12x and then plus 36. So I see that x times 6 is 6x, double it is 12x, but there's a minus here. So it's going to factor into x minus 6 times x minus 6, but we want you to write that as x minus 6 as a quantity squared. This is a binomial squared. All right, so now I'm saying write each quadratic function in vertex form. Find the vertex in the axis of symmetry. Slide it up. All right, so right now, when I'm completing the square, I want the two terms with an x on the same side. So I'm going to go ahead and subtract away 17 from both sides. So f of x, which is the same as y, minus 17 equals x squared minus 10x. I look at that linear term. I look at the coefficient, right, the b. I take that value, the negative 10, I split it in half. So that's negative 5. And then I square it, which makes positive 25. So now I'm going to balance my equation by adding that 25 to both sides. So what I do to one side, I have to do to the other. I have to always balance my equation. Now the whole point of doing that is because right here on this side, I've created a perfect square trinomial that factors into a binomial square. So if I clean up the left, f of x plus 8 equals, right, when I factor this, it becomes x minus 5 as a quantity squared. Last thing to do is take away the 8. And my function is f of x is equal to, in parentheses, x minus 5 as a quantity squared, take away 8. Let me transfer that here. All right, so there is my new function in vertex form. So then I should be able to identify that my vertex, 5 right, 8 down, is at 5 comma negative 8. And my axis of symmetry, always a line, always a vertical line, has to be x equals 5. It's always the vertical line that slices through the vertex, so always the same as the x-coordinate of the vertex. All right, another variation. What's different about this one is that there is a coefficient of 2 in front of the x squared. But I still start it the same way. I want to get my terms with an x on the same side. So I'm going to go ahead and add 7 to both sides. So g of x is equal to, not equal to, g of x plus 7 is equal to 2x squared plus 12x. Okay, now before I can complete the square, I have to divide out that coefficient of 2. So g of x plus 7 equals 2 times, in parentheses, x squared plus 6x. I'm just leaving myself room to complete the square. So I need to think, well, what's going to go in that position, right? I'm going to split this and square it and get a number right here. So I'm going to take that 6, I'm going to split it in half, gets me 3, square it makes 9. All right, so on the left-hand side, I have g of x plus 7. I'm going to leave room because there's something else coming. Equals 2 times x squared plus 6x plus 9. Now, it looks like I've added 9 over here, but I really have added 2 times 9, right? Because if I distribute this side back out, I have the 2x squared plus 12x plus 18. So I need to add 18 to the other side to keep it balanced. So now combine the like terms, right? G of x plus 25 equals 2 times. Again, this is now a perfect square trinomial. It factors into a binomial squared. It factors into x plus 3 as a quantity squared. Okay, last thing to do is take away the 25. So now g of x is equal to 2 times, in parentheses, x plus 3 as a quantity squared, and then take away 25. And then transfer it over here. All right, so that is my new function in vertex form. I can see that there would be a vertical stretch of 2. I'd be moving 3 units left and 25 units down. So my vertex would be at -3, -25. And then my axis of symmetry, always a vertical line that slices through the vertex. So x equals -3. All right, one more variation and then we're done. All right, in this last one, what makes this one different? Now I see a -3 as that leading coefficient, right? It's the number that's in front of my quadratic, right here, the x squared. All right, so then again, first step, get the 2 terms with the x together. So take away 1 from each side. So h of x minus 1 equals -3x squared plus 24x. Okay, I cannot complete the square until I divide out that leading coefficient of -3. So h of x minus 1 equals -3 times x squared minus 8x, and I'm just leaving room, acknowledging that I need something to go here that completes the square. Don't forget, though, that you divided out that -3 initially. So looking at that -8, I'm going to split it in half. Gets me -4. I'm going to square it. And that gets me 16. So even though I'm going to put a 16 right in here, I have to remember that I'm really multiplying by a -3 times that 16. So when I rewrite this, I have h of x minus 1. I'm going to leave room to add something. Equals -3 times, in parentheses, x squared minus 8x plus 16. Okay, again, it looks like I added 16, but really, if I distribute that -3 back, I'd have -3x squared plus 24x minus 48. So I need to subtract 48 from the other side to balance my equation. So now I have h of x minus 49 equals -3 times, this factors into x minus 4 as a quantity squared. Now add that 49 to the other side, and we've done our job. So h of x is equal to -3 parentheses x minus 4 as a quantity squared plus 49. Okay, I'm just going to transfer that right here. So -3 parentheses x minus 4 quantity squared plus 49. So that's telling me in terms of the transformations that there's a vertical flip, right? It opens down, 4 right, 49 up. My vertex would be at 4, 49. And my axis of symmetry would be x equals 4. All right, have a good day.